Okay, hey everyone. We'll start. Tushar, can you just confirm whether my audio is fine?
Just a minute.
Sure. Okay, thank you, Omkar. Okay, we'll start now. So yeah, thank you so much for coming into the Advanced Git workshop. Today's day 2, and we'll be covering Git internals. Don't worry if you've not attended day 1. This workshop is isolated in itself. So yeah, thank you so much for coming in. Before I begin, I'll just let me just preface this with that this is getting into the internal working of Git. So this talk does assume that you have some hands-on experience with Git. I will not be explaining every command that I use, like git commit, git add, and all. I will not be explaining what they are doing and everything. You should have some experience with Git before getting into this talk. Also, it is not going to be like yesterday's talk, wherein it is going to be because it is going to be a little more confusing and a little more complicated. So just bear with me if you have questions. Please do ask. I will be waiting at regular intervals for questions. Okay. So, and also I request that the questions are related to whatever was done, and not to like run too far ahead, because that breaks the flow of the talk. So yeah. Other than that, what are we going to do today? Today we are going to basically look into two main things. Which one is the hidden .git folder. Like we'll go through all the files and what they are and why are they used. Why do we need these files? And the second thing is we're going to look into how Git works and what are the Git objects that are used. This is going to be a long one. So yeah, other than that, I think Tushar is going to paste a link in the chat for RSVPing to this session. I would request you to please RSVP on that portal so that we can send you the emails with the recording and everything and the other resources for this talk. So yeah, that'll come in the chat soon. And other than that, I think we can start. Yeah, Tushar just pasted that. I would request all of you to click on that and just RSVP so that we have a record that you attended. All right. Tushar, am I missing anything?
I don't think so. You're good to go. All the best.
Okay. Thank you. Can we have related questions, please? Anywho. Okay, so thank you for coming in. Let's just give me a minute. I need to share my screen and all that stuff. Okay, so let me start by introducing myself. Hi, I'm Harsh Kapadia. I'm a 4th year IT student at Thadamashani Engineering College. And I have been, I'm mostly a full stack web developer. I really like Git. And just yesterday, I received an email that I'm a GitHub campus expert now. So that's nice. So yeah, that is about me. And I'm also the founder of our tech community, one of the communities collaborating to make this event possible. So yeah, and tonight we have a sort of informal discussion. Details will come in the chat. So if you want to attend that session by OTC, you can come in as well. So yeah. Please note that you don't need to write down or note anything if you are noting down stuff that I'm going to be telling you. Please don't. I already have everything written down for you. Whatever I'm going to explain, everything is already written down in articles. I'll share the link in the chat as well at the end of the talk. So just don't note down anything. Just pay attention and ask questions if you have them. I'll try to answer whatever I can and how much ever I know. Other than that, maybe one of my friend Karthik will help in the chat. So yeah. Okay, now this session is on Git internals. So why should we get into the internals of Git, right? Why should you pay attention here? So basically, when you get into the internals of something, you obviously understand it better and you understand what is going on and how things are working. So when you are using the tool yourself, your workflow improves, your understanding of what is going on improves, so you're able to use the tool better. You're also able to come to know okay, why is this happening? Okay, if there's an error, okay, this might be the issue, and you are able to debug things better and stuff like that. So getting into the internals of some tool or anything like that is always really awesome, and I would recommend doing that. I personally have learned so much by getting into, like, just looking into files and searching up online. Why is this file required? What is this file about? How do I check the contents of this file? How is everything related to each other? And once you sort of get into that, and you're like, wow, you have that sort of eureka moment, and you're like, wow, the person who designed this is so awesome. And and it also, the second point that I wanted to cover was that you sort of learn how systems are designed, how things are designed. So you sort of get that logical thinking that, oh, okay, wow, they faced this problem, so they did this, and okay, this is such a good way of handling this particular thing. This logical thinking might not come with something like competitive programming or something, wherein it's agreed, it's logical, but no one is going to teach you this kind of designing a system or something through that. This you're only going to learn if you would look at the tools existing and you try to understand why something was done. Okay, and that will help you build better software and sort of plan out your software much better, and will help you in architecting some system or running out a system, right? So that is why I think it is really very important that you get into the internals of things, and that is also one of the reasons why I got into it. I just find it interesting, and I was like, how the hell does this work? So curiosity is also a major part of it. So yeah, that being said, let's sort of get into the first part of this talk, which is on the Git directory. Okay, so I hope you know that whenever we execute the git init command, which initializes a repository, Git creates a hidden folder called .git in the directory, right? So we are going to go through each and every file over there and going to tell you why that file is required and what it does. And then we'll sort of add more files to it and sort of see which files are getting changed in that hidden directory, and I'll explain why those files are getting changed and yada yada. So, okay, so I'll get into that. Let me just present my screen. Screen. Okay. Okay, I hope you can see my screen. Great. Yes, Tushar, you wanted to say something?
Yes, it's visible.
Okay, thank you. Okay, so this is going to be our sort of playground. So I'm just going to create a new folder here. I'm going to call it Git_internals. Okay. Getting into this, I have Windows terminal open over here. I'm going to use Git bash for this, but you can use anything. Git bash is just as a nice GUI. Okay, so let's get into the Git internals folder. Now I'm going to, obviously there's an empty directory. So I'm just going to create the local Git repository. Great, so we have a Git repository, and what did Git do? See, we have this hidden .git folder. Okay, if you want to look at it here, see. Okay, so let's get into this cd.git. Okay, now let's look at all the files again. Okay, so we have 3 files and 4 directories. Okay, we're going to get into each of them now. So yeah, let's begin. Let's start with config. Okay, what is this config file? Let me print out the file. Okay, so basically this has some configuration for local repository. But it basically instructs Git on what you're supposed to do. What else does it have? Let me show it in another tab. So I'm going to go into another project of mine, and I'm going to go into the .git directory again, and let me print out the config file. Okay, so see, these things is what you see here as well. Okay, but there is some additional stuff here. Now, what is going on? So just to let you know what this thing is, this Git basics thing is, this is one of my projects that I'm going to be teaching you from. Okay, so this is the this is the sort of site that I've created for you all. So before that, let me just show you the branches and everything so that you understand where I'm coming from. Otherwise, you'll be super confused. My bad. Okay, so this repository has two branches, main and GH pages, okay, GitHub pages. Okay, so we have two branches on this repository, just to let you know, because I'm going to be referring to all of that stuff. Okay, so now that you know that this has two branches and stuff, so now obviously we have our alias here, the remote repository, which is this repository that I showed you on GitHub, this one. Okay, so if you see the URL here, it is the same as this one here. Okay, so our remote repository alias is origin, that is stored in the config file. Then we have two branches, so it's telling me which local branches do I have. Okay, and do they have corresponding remote branches? So where is the remote branch stored? It's stored on the alias called origin, because remember, you can have various aliases. You can also have something ABC, which points to some other random repository. Okay, so it's telling me that this branch's remote is origin. That means this particular repository, and it's telling me if you want to merge into that branch, you have to you can find it over here. Now, what is this ref/head/main? That is one of the folders that you saw here. Refs, if you see here, refs. We'll get into this later. So for now, just remember that if we want to merge something, Git has said that, okay, go to this particular file and you'll find where you want to start merging all of the content from. Okay, so we'll look into what stuff goes on over here. So don't worry about it for now. For now, just know that the config file has some particular local configuration for this particular repository. So if you change a value here, this will not affect any other repository. It will only affect this one. Okay, and it has some information about your remote repository and branches. Okay, so that is the config file. Okay, then we have the description file. This is not really important now, but I'll just show you. It is basically the description of the repository. It's like it's like what we write over here as a description on GitHub, but it's not the same, obviously. So this file was basically used in TSEC. Okay, this file was basically used when there was a program called Git Web. So it still exists, but nobody uses that program, and that program called Git Web uses this file to show the description of the repository. But it's pretty redundant now because nobody uses it. So yeah, no need to edit this file. You can just add whatever you want to this. So yeah, not really important. Okay, now head. This is an extremely important file. So I'll get into it in a bit. Let's go to hooks first. Okay, so as you can see, it's in blue, so it's a directory, right? So let me go to the hooks directory. Okay, I'm going to print out everything. So as you can see, there are certain things, something.sample, something.sample. I'm just going to get into one of them and show you what they are. Okay, so I'm going to use Vim here. It's just an editor, VI improved. Okay, so I don't know if you can see this color, but that's okay. You don't need to read this. So basically, this is if you can see the shebang here, this is pointing to a shell, to shell, right? So this is a shell script basically. So what is going on over here? So basically, Git has these scripts. Git provides you these scripts, right? So what is going on? So the hooks. So this file is called hooks. So you can run these scripts. These are shell scripts. So you can run these scripts whenever you are committing or before committing. So when you type git commit, if you want certain commands to run before committing, you can configure them here. So see, there's a script called pre-commit, right? So when you type git commit, so this script will run, right? Because before committing, there has to be some task that you want to do. Maybe you want to lint the code, you want to check, you have a linter on your in your code, and you want, before committing, the linter has to go through the code, and if there are no warnings and errors, only then can the commit proceed. So if you want to put in that logic, you have to use hooks in Git, and you have to add a pre-commit hook. Okay, so there are loads of such hooks that you can get into, but we are obviously not going to get into any hooks right now. I'm just explaining what these files and what this directory is. Okay, so we went to config, we went to description, we went to hooks. Okay, now we will go to the info directory, sorry.
Just 1 second, Harsh. Can you go back to the Meet screen and make the layout sidebar? It's not visible on YouTube.
Okay, my bad. Yeah. Give me a minute. Point is, Tushar, it is visible, but OBS is not capturing it. So yeah, just direct people to Google Meet.
Okay.
And sadly, it's not getting recorded properly as well. So yeah, I'll have to give the talk again. But anywho, so yeah, this is the config file. This is the description file. We got into it, hooks, and now let's get into the info directory. Okay, so I'm just going to do one in the hooks directory. Let me go back and let's get into the info directory. Okay, we're in the info directory. Let's just check out what is going on. Okay, so it has only one file. What is this file? Let us print it out. Okay, it printed some stuff. Okay, now what's going on? What is the exclude file? Let me tell you. So is there anyone here who doesn't know about Git Ignore, about the Git Ignore file? Is there anyone here? Please let me know if you don't know what the Git Ignore file is. Nidhi, you don't know it?
No.
Okay, anyone else?
Me too. Like
Okay,
I have heard of it.
Okay, no problem, absolutely no problem. I'll show it to you. So okay, if you see this file here, it's got a dot, so it's .git ignore. So basically, a git ignore file is basically it tells Git, okay, please ignore these files locally. Any changes here, and these files do not have to be committed. Okay, it's just telling Git to ignore these files. Okay. So .vs code is usually not committed because it has some settings which are local to your own machine, right? That's why usually it's ignored. Okay, now let me show this to you on the Geo as well so that you're not confused. Let me go to my Git physics project and I'll just show it to you once. Open with code. Okay, so let me collapse everything and let Git load, let it start all the extensions and everything. VS Code. Anywho, so yeah, if you see this build file here, this build folder is right here. So basically, this is the output of the. This is basically a folder that I do not want people to be uploaded on the repository. If you see the repository here. If you see the repository here, there is no build folder over here, right? This is build.sh, that is a file. There is no build folder here, but in my local in my local repository, there is a folder called build. So what am I telling Git by adding this build folder to the Git ignore file? Okay, Git, you are not supposed to track this file. This is not for you. Just ignore this file. Okay. So I'm just telling Git to ignore this file. So this build folder will never get committed or added or anything like that. Okay, so that is basically a Git ignore file. Okay, so this file basically affects all repositories. So if anyone clones a repository, if anyone clones a repository or anyone and they work on whatever and they have a build folder as well, so that is not going to be added or committed on even on their end. Okay, so this Git ignore file affects all the repositories that have it. Okay. Now, did you understand that, by the way? Any doubts on the Git ignore file?
I have a doubt, like what kind of files are ignored in Git ignore?
You can ignore whatever you want to. So I ignored an entire folder. So anything in that folder, in the build folder, won't get included. So you can choose whichever file you want. You can choose, okay, I don't want txt files. You can choose to say, okay, I don't want the entire build folder. You can do anything you want to. Okay.
So other person can see like what all files we have ignored or only.
Yes, they can. Yeah, that's exactly what I told you, right? So if you clone this repository and you create a build folder at your end, then it won't be, you can't add it or commit it. Why? Because it's already in the Git ignore file that you have.
Okay.
Okay. So what if there is a scenario? Why am I talking about Git ignore here? Because Git exclude is, this exclude file is something similar, but it is only for your local repository. So for example, if you have a to-do file, okay, and you want to say, okay, I have to do these things in this project, but you don't want that to-do file to appear on your remote repository that is here. You don't want to make it appear here. So you have two options. You can either put it in the Git ignore file or you can put it in the exclude file. Now, what is the difference in so adding it to both of them will not make it appear here. Okay, the whatever files that the to-do file that you added. Okay, it won't appear here even if you add it to the Git Ignore file or even if you add it to the exclude file. Okay, but what is the difference then? Why are there two separate files? So the Git Ignore file is in the repository and it affects everyone who clones your repository. Okay, so this to-do file, if you add it over, and what happens if you add the to-do here, it will only be excluded for your local repository. Okay, so you don't modify this file for everyone. So if there is a legit to-do file that needs to be added to this repository, so someone else can do that because it's not present in the Git Ignore file. But locally, if you have a some random to-do file that you don't want to appear on the remote repository, and you also don't want to change the Git Ignore file so that everyone else's to-do file gets ignored. So what you can do, you can just add the file over here. So exclude is your Git Ignore for the local repository. Got it? Any doubts here? Anyone not understanding that?
I did not understand the difference between like exclude and Git Ignore. Can you just come again in brief?
Yeah, sure. So if you add something to the exclude file, it will get ignored just like the Git Ignored file, but it won't. Others won't be able to see it. So the Git Ignore file is not affected. So if you have a to-do file, that to-do file can be added in your repository because it's not in the Git Ignore file, right? This exclude file does not appear on GitHub anywhere. So locally, you are ignoring something.
Okay, cool. Thanks.
Okay, anyone not understanding that? Still not understanding? Okay. Great. So what are we going to do? We went through the config file, we went through the description file, we went through hooks, we went through info where we saw the exclude file. Now objects is a very important directory. This is going to take up the major. This is the second part that we're going to get into. It's a major chunk of this talk. So I'm not going to get into it right now. And then there is this refs file. Okay. What are these files? Okay. So before getting into the refs directory, I'm going to take you to head. Okay. So what is this head file? Okay. Let's cat it out. Okay, cat head. Okay, so it is telling me, so if you remember a linked list, the data structure linked list, it has a head pointer, right, which points the latest to the first one, right? Whichever is the first node in the linked list, it points to that, right? So this is something similar where head points to the latest commit in the branch that you are. Okay, so if we check, so basically head points to the latest commit in your branch. Now, how is the commit uniquely referred to? By its SHA, right? By its SHA-1 hash, the 40 character hexadecimal string that I told you about yesterday. So that is what the head points to. Okay. Now head, but why is there instead of the SHA, there is some text here. Okay. Now, why is that? Okay. Let's have a look at this particular this reference. Let's have a look at this reference. Okay. So now that we have looked at head and head is also pointing to this directory, let's get into this directory. Okay, let's see what it has. Okay, let's do cd refs. Okay, let's do ls to list out everything. Okay, it has two directories, heads and tags. Okay, so we have to get into the heads one. Okay, I'll explain to you what tags is later on, not really important right now. cd heads. Okay, now let me list out stuff here. Oh, it's empty, right? There should be something called main, right? It's showing me there should be something called main. Okay, it's empty right now. So what's the issue? Okay, so let me show you. Okay, let me tell you why it's empty and everything. Okay, we are back to our Git Basics project. Okay, so here let us again cat out the head file, print out the head file. Okay. Okay. Here I print out a head file. It's again pointing to ref/head/main. Okay, so let's go to that. cd refs/heads/main. Okay, let me just go to heads. Okay, and now I'll list out stuff. Okay, it has this main file. Okay, now let's see what main has. Okay, I'm going to print out main. Ooh, now you finally get that SHA-1 hash. Okay, so what is going on over here? Okay, so your head is pointing to the latest commit in the branch that you are currently in. Which branch are you currently in? The command to check that is git branch. Okay, so we have two branches, GHPs and main, and the one in green here, main, that is the branch we are in. You can see the star here. So that is why head is pointing to the main branch. Okay, so it is pointing to main, and once I get inside this ref/head/main, so the reference to the main branch is stored in this folder, and when I print the main file, it gives me the latest commit. And just to show you that this is actually the latest commit, let me just show it to you here. If I click here, yep, look at this. Okay, wait. If you, I don't know if you can see this stuff in blue, but it says A002148. And if we come back here, look at this, A002148. Okay, so we have the same hash here and the same hash here. So this is, and this is the latest hash. Okay, so your head is pointing to the latest commit. Okay, and this is how it is pointing. So your refs folder basically, let me show it to you. So your refs directly basically has this heads folder, okay, which has the branch name. Okay, that's what we saw here, right? Yep. Okay. So, oh no, sorry, my bad. Where is the refs folder? Yeah, ref/head has the branch name. Okay. Yeah, ref/head has the branch name. Okay. So, if I step up one by one, and I'm in refs, if I do an ls now, okay, so we have heads, remotes, tags. Okay, and if you see here, in the refs directory, we have heads, remotes, and tags. Stash is for something else, it's for git stash. Let's not get into it right now. Okay, so what is this remote thing now? So if you get into remotes and print it again, okay, so we have a directory called origin. Okay, okay, let's get into origin now. cd origin. And if you remember, origin is the alias for my Git remote repository. Okay, and I list down origin here. Oops, my bad. ls. Okay, so it is giving me 4 values: gh pages, head, image bot, and main. Okay, so what is it doing here? If we go back to our remote repository and check, we have 2 branches, right? Main and gh pages. Okay, so this output here has gh pages and main, right? Because so remotes is basically our remote repository. Origin is the name of this remote repository that we have given. Okay, and head is the head file of the remote repository. Okay, ImageBot is another branch, but that has been deleted. It's not deleted locally, but it was deleted from GitHub. So yeah, don't worry about that. But it was another branch. Okay, and head is the head file of the remote repository. Okay, so basically your refs, the refs directory is basically storing the reference to the latest reference to every branch. Okay, so that means on the remote repository, I have these 4 branches, and all of the, and these stores the latest commit of each branch. Okay, so when I was in the when I was in the heads directory, there was the main branch here. So this file has the latest commit in the local repository of the main branch. Okay, so it has the latest commit of the main branch in the local repository. So that is what the refs folder is for. Okay, it has the reference to the latest commit of each branch, whether it be in locally or be it remotely, or tags and stashes for different stuff. Let's not get into it right now. This is essentially the essence of the refs directory. Anyone did not understand anything here?
Can you do a cat? Can you go back to your bash?
Yeah.
And can you do cat gh pages?
Sure. I don't know what happened to my terminal. It's not typing. Weird. Let me just open another one.
So basically, it will just keep updating these references every time someone pushes a commit in one of these branches.
Yes.
Okay.
I'll just show it to you. No problem. Slash notes. Yes. Oh yes, yes. CD original.
Okay. So it will just keep updating this file, right?
Yes, it depends. Now, if you don't have internet connection and your remote is updated, so this will lag behind, obviously. But for your local repository, so in the heads directory, that will always be updated because it's a local repository. Now, this is dependent on your internet connection. Okay, every time you sort of push and pull, that time these things get updated. Git fetches them for you. But if you don't have internet connection, this is obviously going to lag behind a little. Okay. So when it's considered, when you consider the remote repository, but when it's the local repository, that means when you are in ref/head, that time it is always updated because that is pertaining to the local repository. Okay.
Okay, got it.
Anyone else? Anything? Okay, I'm presuming everyone got it. All right. So now let us get back to our initial repository. Let me clear the screen.
Hello.
Yes, yes.
I want to ask something. You just said in the remote, in the refs remote, if there's no internet connection, it won't be updated, right? So since it's not updated, if you do a pull request, then it will get updated, right? But then you can't push it because
No, you
you're
can't.
lagging back. You can't
Because you don't have internet, so you can't push it, right?
Okay, and even if you if you get an internet connection, then will it get updated automatically?
Yes.
Okay.
No,
okay.
not automatically. You only after a pull push. I think you'll if you pull push to that particular branch, that will get updated. If you want to forcibly like update it and that kind of stuff, I think you have to do a git fetch for that particular branch. But if you randomly git push in that branch, it will get updated before doing all that transfer.
Okay. I got it.
Okay.
Also, one more question.
Yeah. Go ahead.
If I just want to understand that in these directories we have these files that is saving references for the last commit in each branch. So why are we saving it in the .git folder? Is it for GitHub to keep a track, or is it for us?
For us. So GitHub has its own .git directory. So your remote repository on GitHub has its own .git directory and it does its own stuff over there. And this is for your Git repository. So if you switch to a new branch, how does Git know which commit to go to? If you say git switch GH pages, if I put that command to switch to a new branch, how does Git know where is the latest commit of that branch? So it goes to the refs directory, it goes to head, it goes to search, it searches for the GH pages branch, and whatever is GH pages file, whatever is inside that file, whichever commit, that is the latest commit. So it checks out that particular commit in that branch.
So technically, it's not for us. It's Git is using that, right? Because
Yeah.
we will never.
Nothing in the .git directory is for us.
Okay. All right.
It is a reference for Git to be able to move about fast and to know where to move.
Right. Makes sense.
Okay. Anyone else? Any questions? History. I'm coming to it. Omkar, I'm coming to history. I'm coming to it. There's a logs folder that's missing right now. I'm coming to it. So, good you asked that question. That reminded me. I did an ls here and there was nothing here, right, in this repository, in our Git Internals repository. Whereas our head was showing, if we cat the head file, cd head. If you are saying head, then it is saying, okay, go to this particular repository, go to this file. But when we get into ref/head, main is missing over here. Why? That is because there is no commit over here. There is no addition of file. There is nothing going on here. Okay. So there is basically no head. The linked list has not been created right now. Then how can there be a head, right? So it is pointing to this branch because that is the default branch. So if I just go back, okay. So if you see the default branch of the repository is main. Okay. So that is why this it is pointing to this main branch. But actually there is no commit in the main branch right now. The branch is not created. Whenever it will be sort of created, that time the first commit will be in the main branch. So that is why it has this particular reference, but actually the file has not been created in the ref/head directory. So that is why I will create a file. I will soon create a file and I'll show you that, okay, things are actually working. I'm not joking here. Okay. But before that, we have one more folder to go to before I sort of create files and stuff. Okay, let me get into the .git directory again. So we went to config, we went to description, we went to head, we went to hooks, we went to info, we went to refs. Okay, now this file, this directory. This is the single most important directory. I mean, not the most important, but an extremely important directory here. This is your Git objects are stored here. Everything, all your content, everything is in this directory. Okay, so extremely important directory here. Pay attention. Okay, I'm just going to look into this. Okay, there are two directories here, info and pack. Okay, now let me show you a repository. This is a repository with 397 commits. Okay, there are 397 commits on this repository. I'm going to go inside the objects directory here. Okay, and now just don't get scared. I'm just going to print out what is there here. Okay. Okay. There are a lot of directories here, and at the end you see the info and the pack directories, and over here you see there are only the info and pack directories. Okay. So what the hell is all of this? Okay. So before I tell you what the hell all that is, let me just cd into the first folder here. You see 00. So let me cd into 00. Oh, I pressed Yep. And now let me print out what is there in this particular file. Okay, so again gibberish, right? 1, 2, 3, 4, 5, 6. 6 files are there here with some random numbers. And I think a few of you would have guessed what this is. Yes, this is the SHA-1 hash of the commit. Okay. Or commit tree blob, whatever. Okay, whatever that is. This is the SHA-1 hash. Now for what that is, I will tell you later on. So what is going on? So these are 38 characters. Okay. And these are the first 2 characters. So if you remember SHA-1, the SHA-1 algorithm, whenever it hashes content, it always produces a 40 character string. Okay. So what Git does, it takes the first 2 characters of that and makes a directory in the objects directory. Okay. So first 2 characters of that 40 character string is used to create a directory in the objects folder, and the remaining 38 characters are the name of the file inside that directory. Okay. So this is called bucketing. Okay. So Git does bucketing inside the objects directory, and it basically this helps. I think CP peeps will be all over this because it basically makes it easier to search for files. Just imagine searching for about 600 files or so, because 397 commits means around almost double the number of files. So not even double, even more. So around 600 files or something. So just imagine searching for one particular file in 600 files. That is crazy, right? So it is so much easier to search for the first 2 letters of that particular SHA, and then using then getting inside that folder and then only searching in 6 files. Okay, just imagine if you wanted to access some file in E0. Okay, let's get inside the E0 folder. Okay, so imagine you wanted this particular file. Okay, you wanted the file E0E3BB. Okay, just imagine searching in 600 files for that. So what Git did, okay, search for E0. Okay, that will make things easier for you. And then out of whatever 4 files you have, just search for the one with the remaining part of what you asked for, E3BB. Okay, so that makes your search much faster. And here is where Git is also reducing time for whenever you say, okay, Git, check out this particular thing, this particular commit. So it has to go and sort of find all the files and everything, right? So this is how it makes it easier. The concept is known as bucketing. Okay, now what is there inside this file, and all of that we will not get into right now. That is there's a huge part of the that is basically what we are going to do in the second part, exploring the content. For now, I'll just cat it for you. Okay, this is the content of the file. Okay, all gibberish. Okay, we'll get into this. Why is this gibberish? What is going on? We'll get into it. Don't worry. Okay, so right now, just know that it's storage place for all your content. We'll get into, if we have time and if I can remember stuff properly, we get in the info and pack directories as well. But for now, just remember that this is your storage. It's basically a database kind of thing. Okay, for all your content of all the stuff that you've ever done, your history. Okay, history stored here. Now, what is the sequence of the history and all that? How that is found, I'll tell you. Okay, Omkar, wait. Okay, so let me just go out. Then we start adding files and doing stuff. But oh, okay. Okay, so now before we let me just print out. Okay. Oh, I'm in the wrong. Okay, so here we have seen the config file, we have seen the description file, we've seen head, we've seen all of them. Okay, we've seen everything here. Okay, so now and let me show you. This is the .git directory of the Git Basics project. So there are loads of things that we are missing, right? So, and let me show you all the possible options that the .git directory can have. Not all the possible options. I couldn't find all of them, obviously. So yeah, just see, these are the number of option things that I could find. I'm sure there are many more, but yeah, so we are not going into all of this stuff. Okay, we're not getting into rebase stuff, we're not getting into Git LFS stuff and all of that, but we'll explore all the major things that you use that helps Git work. You're not going to use LFS a lot, so I'm not going to get into that. Even I don't know how it works, by the way, but I'm pretty sure it's the same because I can see the same sort of stuff happening here. But anywho, so yeah, these are all the possible options. So we've explored just some of them for now. Okay, so let's get into more of them. Before that, I'm going to wait for doubts again. Did anyone not understand something here?
Hello, Harsh.
Yes, Chirag?
Harsh, can you open the objects folder?
Which one? Git Basics object folder?
The one which has so many folders.
Okay. The Git Basics one. Objects. Yes.
So, when does a particular folder gets created? Means at which instance?
Don't worry about that. I told you I will get into the objects directory of how is this created, what is going on, why are there so many files, why am I telling you that there are maybe around 500 to 600 files here when there are only 397 commits, what is going on? So I'll get into that, don't worry. I'll show you how everything is created. We'll start from a blank repository and get going, okay? Don't worry.
Okay.
Okay. Anyone, anything else?
PyE has an interesting question. He says that if all the combinations of the first two letters are exhausted, what then?
So then it's not found. File is not found.
No, he's talking about the number of commits. So it's like
okay. Doesn't matter if all of them are exhausted, then it'll go into the bucket, right? I mean, what? It doesn't matter if all of them are exhausted, because we are doing bucketing here. We are not. So there's a 40 character string which is unique. It doesn't have to. The first two characters don't have to be unique every time. Okay. So even if all of them are occupied, it will just go into that. So having a collision in a 40 character string is like almost unheard of. Okay. So two different strings having the same hash is almost unheard of. Okay. In a 40 character string, it's almost impossible. Okay. So although it has happened before, and there are cases, but very rare. So if you can speak up, I hope you got that. Okay, great. Anyone else, anything? Okay, I'm presuming everyone got it and everyone has no questions. Now we are going to get into something more sort of, how do I put this? We are going to get into more files, okay? So for now, I'm just going to clear this. Let me increase the font for you. Okay, I'll not do that because let's print it out again. Okay, so please take note that we have 4, 5, 6, 7 files here. Okay, 7 things here, files and directories. Okay, let me go out. Okay, I'm going to create a new file now. Touch. I'm using the command line, obviously. File1.txt. Okay, I created that. Okay, let us now check whether there was any change here. cd ls.git forward/. Yep. Okay, no changes here. nothing is going on. Okay. Okay, we just created the file. There is nothing going on. I do git status. Okay, there is just this. It's untracked right now. There is nothing going on. Okay, so I'll just do git add now. Git add file one.txt. Oops, spelling. Okay. Now let me check status. Okay, there is something added. Okay, so now that there is something added, let's see what happens to the Git directory. Okay, let me cd into Git ls. Okay, there is something new here. And if we get into the objects directory as well, cd objects ls. Ooh, previously there was only info and pack. Now there is something called e6. Okay, there is some changes going on. Let us get into e6. E6. Let us print out. Ooh, there is this hash. Okay, now let us print this out. Cat. Okay, we have gibberish. What is this? We'll get into it later. For now, this is the content of the file. Okay, what this is, I'm not going to tell you right now. Suspense, right? No, I'm joking. Anyways, I'll tell you later on, sure, because this is the second half of the talk. We're still on the first one. Okay, so we saw that there is one folder in the objects directory. That is that file that I printed out with gibberish. What is that? I'll tell you later. That is the contents of the file, but why is it that way and all of that? We'll check later. For now, let's concentrate on this file, this index file. Okay. Okay, let us print out the index file. Gibberish again. But at least you can make out here that there is file1.txt, right? So yeah, you can see, and this does not exist before. Okay. So there is this file1.txt, but what the hell is going on here? Why is this gibberish? So let me just, so this has been compressed obviously, but there is a command with which you can look at this. Okay. Is there a question? Okay, apparently something was funny, but anyways, git ls files stage. Okay, so we just staged. Why am I doing all this? Because we just staged a file, right? We just added a file right now, and that is what created this index file, right? That's why I'm adding this stage option. Okay, now let's see what this gives us. So this is whatever output we get now is basically the output of the index file. Okay. Okay, we have something here. What is going on? So there is some 100644 here. This is the, I'll tell you what that is. Wait, this is the 40 character hash of the file. There's this letters number 0 here. What is that? I'll tell you. And then we have this file1.txt here. Okay, which is the name of the file we added, obviously. So this is the name of the file. This file is referring to this particular file. Now we know this hash is actually a file. So yeah, so it is referring to this hash now. Okay. Okay, what is this? This is an octal number. Okay, 100644 is an octal number. Okay, to show you what it means in binary and how it converts, I'll just have to go to here and index where I'm, yeah. Okay, if we see here, this is the same 100644, right? That you see. So if you concentrate here, if you convert octal to binary, so it's basically just 4 in binary is so stuff like that. Okay, so 1 is 001, then 0 is again 3 zeros, then this next 0 is 3 zeros. So basically conversion from octal to binary. Okay, 6 is again this right here. So stuff like that. Okay, if you go for 4, it's 011. Okay, I think you got it. So this is the binary version. Now what is going on? Okay, so it is basically the mode of the file wherein Git is conveying some information. Okay, so the first 6 numbers 10 is basically indicating what type of a file it is. Okay, if it's a regular file, it will be 100 here. You'll see 100 here. The other 2 types of files that it can be a symlink, which is a symbolic link, and it can be a Git link. Git links are used in submodules, if I'm not wrong. Git submodules, that's a different concept altogether. Karthik, please correct me if I'm wrong. Symbolic links are links, again getting into this. They are links, they are basically links to other files. So basically one file acts as a link to another file on your system. So it's something like that. Okay, so no need to get into it right now. So yeah, this is a regular file. There can be 3 types of files. So First is the file type, then the next 3 bits are unused. First 6 bits of a file type, next 3 bits are unused, and then the last 9 bits or the last 3 numbers here in the octal number. This is the Unix file permission. If you remember, there are some Unix file permissions, whether for the group, for the owner and stuff like that. There are lots of file policies. You can, whether the user can read, write, or execute the file, it decides that, the file permissions. So yeah, those last 3 digits are the file permissions. If you want to read more, you can go to this link on what file permissions are. Okay. So we have 3 file types: regular, symlink, and gitlink. So for the first file type, these are the 2 valid Unix permissions, and for symlinks and gitlinks, it's going to be 0. Okay. So this is what this first number was that we saw here. This first number is the file mode. This is the hash. This 0 is what I'm going to explain now, and this is the file name of the added file. Okay. What is this 0 now? So 0 indicates certain things. Okay, so that value can be between 0 and 3. Okay, 0, 1, and 1, 2, and 3. It is called the stage number or the slot. Okay, that is the name of this. Now, what is this and why is this required? This is basically used during merge conflicts. Okay, I have a demonstration of that for you. I created a folder, created a local Git repository, created a merge conflict in there. Okay, so what we are going to do right now, we're going into the Git. So let me list down the files for you. Okay, forget about old Git. That's just something a copy of the .git directory. But we have 3 main files here: the a.txt, c.txt, and d.txt. Okay, now let us check the index file. cd.git/git and cat the index file. Obviously, it's not going to print, so I have to use ls files. Okay, so here we can see C and D have the same 0 as we can as we saw here. This 0 over here we saw, but there is A which has 1, 2, and 3. Okay, what's going on? So 0 indicates that this is a normal regular file. There is absolutely no problem. Everything is fine. Okay. 1, 2, and 3 here, they indicate that, okay, there is some merge conflict going on, and each of these files are different files. So there is one file which is the original file, then one file is the incoming change, and one file has both the changes. Okay. And to show you how this looks properly on the GUI, I'm just going to open VS Code here to show you and what is going on. Okay, so this is our file. Let VS Code start up. We'll wait for VS Code start. Till then, I'll explain to you what 1, 2, and 3 mean. So obviously 1 indicates the base, that is the original version of the file. Okay. 3 indicates the diars version, which means that the file with the incoming changes. Okay. And ours is our version, wherein we had made some changes which got conflicted. Okay. So if you see here, the VS Code GUI is, okay, let me, if you see here, these two have A, the green A is added file, and here it's showing me a exclamation mark. So that means we are in a merge conflict state in this repository. Okay, let me open this file and see. This is a standard case of having changed the same sort of line. So yeah, here it's A, here is B. So Git is in merge conflict state right now. It doesn't know whether to keep A or keep B. So we have to manually resolve this. Anyways, that was not the point. The point is that, okay, so there is a merge conflict going on right now. And how does Git know that there is a merge conflict going on right now? It sees here, okay, this C and D are normal files, 0, 0. And okay, we have some merge conflict going on over here. And how does it show you, okay, this is the incoming, this is this is which change and what is going on? So it has different versions of files over here. That, okay, incoming change, okay, it is stored in this particular file. That kind of way, okay? The current change, okay, it's in file number this with the one thing, okay? So it's the same file with sort of different content in each of them, and what each content is, there's a code for that. It's called the slot or the stage number, okay? So this is what the index file is. So essentially, the index file is your staging area, okay? your entire git status, git add, and all of that, all of the stuff that you do is basically coming from the index file. Everything is stored in the index file, and whatever changes you make to the staging area when you run git status or whatever you do, it first goes and checks the index file, because that is your staging area. Okay, so staging area equivalent to index file. That is why it is a very important file. It's basically your entire staging area. Okay, and if you have time later on, I would recommend reading through all of this stuff and looking at this image as well later on. So yeah, it's basically your staging area. Great. So now we have seen, let me go back to terminal. I should open a new one. CD internals. Let's start. Okay, so we went to the config file, we went to everything, and we saw index. We saw there's a directory in the objects file, and it has some gibberish stored in it. What that is, I will get into later on. But did you not understand anything right now till now? Any questions till now? Okay, I'm presuming everyone got it. Okay, so okay, I think we are done with part 1. Let me just check. We are not. Okay. Now let us get to this one. Okay, what is going on over here? So we'll add some more files. Okay, we added something. So we created the index file and we created one object here. It was the E6 directory. Let me just show it to you. ls.git/objects obj. Okay, so we have that E6 directory here. Okay, just remember that much for now. Okay, so we have added a file. Okay, now we are going to commit it. Initial commit. Okay. Let us check what happened to the .git directory. Before that, I'll just show you git log. Hey, we have a commit. Okay. Now let's see what is going on in the .git directory. Remember, initial state was this. Now let us see the new state. .git ls. Ooh, commit edit message has been added. Other than that, let's look into the objects directory. Let's see what's going on there. cd objects ls. Ooh, 2 new files. Okay, so E6 was there initially, as we are seeing here, and now two new files. Okay, let us get into that. 25 ls. Again, something random, and I'm sure you know if I print it, it's going to print some gibberish. Okay, yeah. Content we'll see later on, part 2 of talk. Okay, so what is this file now? Oh, sorry, I went to 2. So yeah, new files created, commit edit message, and in the objects directory there were 2 new files created. One was in 25 and one was in 86. Okay, just to show you, even in 86 there's only one file. Yep, another file is created. What they are, we'll see later on. Okay, and oh, one more thing, even the logs directory was created. So 4 things: commit edit message, logs directory, and objects, and 2 directories in objects. Okay. So first let us start. Or does anyone have any question? Okay, I'm sorry. Okay, so first let us get into this commit edit message thing. What is this? Okay, it's a file, right? So I'm going to, I'm not in the current directory. Okay, I'm going to cat the file. What's the name? Committed. Okay, so it's giving me initial commit. So I think you got what this file is for. This file is basically to store your commit message, so Git can access the last commit message fast, and if you want to make any changes, it can do that fast. So it's just a normal file which stores your latest commit message. Okay, and you can go and edit it and stuff like that. Okay, so it's just a random file. Okay, to edit your commit message. Now let's get into this file. What is this logs thing? Okay, Omkar, here is the history for you. Anyways, cd logs, if he's still there. Yeah, ls. Okay, so we have something called head and we have something called refs inside the logs folder. Okay, don't get confused with the refs that is there outside. Okay, we are right now inside the logs directory, and inside the logs directory we have head and refs again. Okay, so let's print out the head file, cat head. Okay, huge output. What is this? This is the, because this is the first, okay, let me not show it this way, let me show it here. Okay, now here let us get into cd.git/logs. Okay, I'm going to ls. I'm going to again print out the head file. Don't get scared. Okay, we have this huge output. Obviously, there are 397 commits, so there's going to be a huge output. So yeah, if you see, there is this 40 character string here, there's this 40 character string here, and this 40 character string gets repeated in the next line. Okay, so what is going on over here? Git is sort of maintaining a how do I say, it's a sort of a linked list kind of thing where it's pointing, okay, the next one is here, the next one is saying, okay, the previous one was this one, and this particular commit has this particular value, that kind of thing. Okay, it's same here because this was just a reset thing, but yeah, it has a pointer to the next one and that kind of thing. It depends on what kind of commit it is. Okay, so why is this 00 here? Because this was the first one. Okay, because it's the first commit, that is why this is not a commit, this is a clone, but whatever is the first sort of operation that you do, that is what you can see. So if we go to our folder, where is it? Here. So our first operation was initializing, so it was a commit. So it was the initial commit, that's why it's commit and initial. Okay, so that's why it's 0 here. What is the hash of that commit? Here is the hash, and if we check git log, see git log 25f48, right? 25f48. Okay, so the first one is the previous commits hash, but first one. So that is why the second one is the hash of that particular operation, and the operation was a commit, so the hash is here. Okay, this is the author of the commit, this is the email of the author of the commit, this is the Unix epoch timestamp. I hope I'm not messing that up. So it's basically the number of seconds that has passed from January 1, 1970. It's I don't know why it's that way, but it is that way. I don't know the history behind it. Maybe Karthik knows. But anyways, so this is a Unix epoch time. This is the number of seconds that have passed from January 1970. That is how you would calculate the time here. When was this file exactly committed? And this is the what do you call it? Time zone. Time zone. Okay. And then this is the operation. This was a initial commit and initial because it's the first commit, and then the commit message. Okay, so let us look at the other options that we can see here. Okay, so this was a clone. I had cloned this repository. So the first operation was a clone here, and from which repository, from which remote URL, it was this one. Okay, that is done. Then there's something, there can be a reset, then there can be, if it's a commit, then there's a commit message at the end, loads of things. So if you amended a commit message, then it has a sort of an amend over here. And now what we have to get to is, yeah, so if it's a pull, there's pull here, there's branch here, checkout, and so lots of types. Basically, it's just recording all the commands that you're doing, whatever you're doing, the head file is sort of recording. Okay, so that's the head file. Now let us get into, if you remember, there was head and then there was the refs as well, right? So the refs folder has the same sort of structure as what we saw in the refs, in the initial refs folder. So I'll just show that to you. ls head and refs. Okay, let us get into refs. Okay, and if I, let's again see heads and remote, same structure again. Okay, so if I get into heads, ls, we have GH pages and we have main. Okay, but remember this was inside the logs directory. Okay, so by logic, if you understood what's going on, by logic you say, okay, this will be the history of the main branch, this will be the history of the GH pages branch. Okay, so let me cat the main branch. Okay, cat main file, enter. Again, don't get shy, it's going to be a huge output again. So yeah, this is basically the history of everything. Okay, this is how you've sort of you've cloned this. What are the commits that you have made after that clone? Was there a pull? What kind of a pull? What kind of a merge was it? It was a fast forward merge after pulling. Then there was a branch, some branch operation. Okay, yeah, I renamed the. I can imagine how irritated Karthik is, but yeah, I renamed the. It was initially called the master branch, but I renamed it to the main branch. So all the operations are written here so that Git can track. Okay, if this person wants me to go to this particular commit, how much do I have to undo? Where do I have to go? Where is this file stored? What happened? So everything is noted down here properly. So yeah, this is how the how it's stored. Okay, so ref/head has the local stuff, and ref/remote will obviously have the remote stuff. cd./remotes ls. Okay, cd obviously origin and ls. Yep, it has ch pages, head, main, master. So it has master as well because there was a master branch initially. It has not deleted this master branch yet. Over here, it has the logs for that. But anywho, so yeah, this is how this is what the logs is. This is basically Git storing. Okay, what is what is the linked list basically? So if you see here, this is the initial commit before it, and see this is the commit before it. And this is the commit of this is the hash of this particular commit. And if you see here, that is what is reflected here. And this is the one for this particular one. So that is how it's sort of linking everything. Okay. So I hope you've understood that. Are there any questions? Because now we'll be moving on to other stuff. So yeah, any questions, anyone? Okay. I think everyone has understood. I'm presuming everyone has understood. Anywho, now, okay, so let's go back to our Git Internals repository, and we saw Git logs has same head, refs, everything. If you get into refs, just to show you, Git, cd refs/heads, okay, and cat main. Okay, see, we have this initial thing. It will be the same in heads and main here because there's only one commit right now. So yeah, exactly same thing. Okay, great. So we've explored the logs directory as well. And just to show it to you properly, the logs directory. So yeah, we have head and we have refs, and refs can itself have the same structure as the initial refs directory. Okay, but the storage is different. It stores the log. Okay, so this basically stores the logs of your doing in the repository. Anywho, now there are some more files that I have not told you about. So here we have we saw index, we saw head, we saw refs. We still have to see what packed refs is. We saw logs. We still have to see what fetch is. We saw commit message. We saw objects. I still have to explain what objects are. We have to see info, config, and I'm not going to explain this to you. Origin head is left, and description we saw. Okay, so I think 3 files are left. Let's start with packed refs. Okay, so I think you saw the refs here. Let's get inside the refs directory. Now this is not the one inside the logs directory. Okay, this is the other one. Go to ls. So we are not going inside this. We are looking at this one. Okay, so if you remember the refs directory, it had all the latest commits of each branch, right? So imagine a scenario wherein a huge repository, like maybe something like Vue.js repository or the React repository or something, huge repositories. Just imagine the number of branches they must be having, and just imagine the number of files in the heads directory, right? Which has the commit for each of the latest files. That occupies so much space, right? And a lot of those branches are not active, right? Maybe just the main branch or some other development branch, maybe just 6 or 7 of them are active, and all the other 50 of them might not be active. How many other branches there are? So there might be, so we are wasting that much space, right? So what does Git do to save space and to reduce access time and stuff? Git packs all those things in separate files into one file. Okay, so let me just show it to you. Okay, so let me show you the refs directory for now. Refs/refs. Then we obviously have heads and tags here. If we go into heads, and this, okay, we have main. Okay, and if I cat main, you always see the hash. Okay, now what I'm going to do, I'm going to run a command called git pack refs all. Okay, now let's see what happens. Okay, I've run this command. Now I'm in the heads directory, right? Refs/head. Okay, now let me ls again. Oh, the file is missing. Okay, the main file that was present here in the heads directory, that is missing now. Okay, it's missing. So where did it go? Let us check the directory. Git directory. Okay, in the .git directory, let me ls again. Okay, so all of them are same except this file. There is some pactrefs file that is going on. Let us cat this file. What is this? Okay, so it said, okay, this hash and this is the reference. Okay, so I think you've understood it, but I'll show it to you again here in a repository which has way more branches. Again. Okay, now let me ls and show you. Okay, see, this one has a pactref as well. Okay, so I had actually run the pactref command. That is why this was created. Otherwise, it would not have been created. So I'm going to cat the file. Okay, so now I think now you're understanding what's going on, how it's saving space, right? Instead of having many directories and files, take everything, put it in one file. Okay, so this is the hash of the latest commit, whatever it was pointing to, and this is the reference. Okay, so now if some branch is being used, okay, then it will be removed from this and that file will be created back again in the refs directory. Okay, so if you see the refs directory, cd refs of this Git basics project, /heads, and here if I ls, you will see that main still exists. Why? Because after running the pactrefs command, I had actually made a few commits. That is why Git actually said, okay, this branch is active, so I will maintain a file for that. Okay, so after you pack all the files, then you will sort of, and once you start whichever file you use now, whichever branch you're using and making commits on, that only those files will exist here. Only those files will exist here. Okay, so yeah, that is how Git is being efficient with space storage. So yeah, that was the pactrefs file. Any doubts here? Okay, I guess not. Now we're going to show you the we're done with pactrefs. We're going to use a fetch head. Okay, now what if you remember what fetch is from yesterday? Fetch is basically I'll show it to you. If you remember what fetch was from yesterday, when we were talking about git pull, I said git internally does a git fetch and then a git merge. Okay, so what is going on? So when you do git fetch, it just gets all the commits and all the files and everything to your local repository. So in the .git folder, they are all stored in the .git folder. But to actually see them over here, you have to merge them. Okay, so fetching will just get the files here and merging will merge it over here. Okay. So yeah, that is, so fetching is just getting stuff from the remote repository to the local repository. Okay, so now we'll see what is this fetch head file. So obviously our repository does not have any, our Git Internals repository does not have any remote. So that is why I'm just going to use the Git basics repository to show it to you. So if you see, there is a file called fetch head here. Okay, I'm just going to cat it, print it. Okay, so here again we have the latest commit. Then we have the branch. This is corresponding to the main branch. Then we have the another latest commit SHA here. Then we have something called not for merge here. Then we have the GH pages branch here. Okay, and it is telling me this branch belongs to which repository, because you can have multiple ones linked, right? So anyways, so why is this not for merge? Why is that text not present here? It's missing here, right? So what's going on? So whichever branch is checked out right now, whichever branch you are on right now, that is the branch. That is basically the one that is currently. If you just say git fetch, this is the branch that will be fetched from the remote. So it will check on main. It will go to remote repository. It will check. Okay, on main, is this the same commit here? So it will check whichever is the latest commit. So right now it is showing A0021. Okay, now let us go to our remote repository, which is this one, and let us check the commits. We are in the main branch right now, so we're checking main branch's commits. Okay, main. What is the commit? A0021. Okay, it's the same. Great. So we have all the latest commits in our local repository. Great. Okay. And let's check for GitHub pages also. I'm not sure whether this is the latest one. Let me check. I think I'd run fetch recently, so it should be the latest one, but let's check. 62CEF. 62CEF. Yes, this is the latest one as well. Okay. So, whenever you let me just run git fetch. Git fetch origin and main. Okay. Okay. So this fetch head. Now you know what this fetch head means here, right? Okay. Now let me cat the file again. Great. So now it is showing me only one of them. Why? Because I specifically mentioned main, right? That's why it removed everything else and it has got this here. Okay. It has updated the fetch. Now if I just say git fetch origin instead of git fetch origin main, see what the output is now. Okay. Now it is outputting both of them, what we saw initially. Okay. So it fetched all the branches in the remote. It fetched that, and whichever branch is checked out, that is the one which is which does not have that not for merge thing. Okay. So whenever you're doing git pull and all of that, it knows, okay, so this is the branch which has to be I have to merge in. I don't have to merge in the GH pages branch if I'm doing git pull. Okay. Why? Because here it is written not for merge. Okay. I'm not checked out. I think if I check out, I'm not sure whether this will work, but if I switch to GH pages, let me see what happens. Git switch GH pages. Okay, let me stash it. Don't worry about what I'm doing right now. You can ignore all of this. Okay, now let me switch to GitHub pages. Okay, I've switched there. Okay, now let me run. Let me see what the cat file, what the fetch head thing has. File has. Okay, cat fetch head. Okay, now if I run, okay, so it didn't change. Okay, let's see if I run git fetch origin. I think now it will show only GH pages, but yeah, let's see what is the output. I just run git fetch origin. It should show the GH pages again. Let's see. Now you see. So because I'm in the git I'm in the GH pages branch, the not for merge is on the main branch. Okay, so that is how when you just run git pull, Git knows, okay, from where do I have to pull it. If you don't run git, if you say git pull origin main, it knows, okay, I have to pull from main. But if you say git pull, if you just say git pull, then where do I have to take it from? So it looks at the latest branch. It sees the fetch file, and okay, wow, okay, now I know which branch I have to pull from. Okay, which is the file to be branch to be fetched from. Okay, so that is what is the fetch head file. Okay, any doubts, anyone? Okay, great. So we have gone through almost all the files. I think I'm going to skip the origin head file and the which one have you missed? Yeah, I'm just going to skip the origin head file. I don't think it's that important. You can always come here and read through what it is. It's really not important. Okay. Let me check. Factrefs is done. Fetch head is done. Okay, we finished the first half of the talk. I know it took long. I'm so sorry. But yeah, I hope you understood stuff. Any doubts here? Now we are going to dive into the basically into Git objects, where we're going to get into tree, commit, blob, and what is the content of that particular file that you could see there. Why was it gibberish? What is going on? So we are going to do that now, getting into part 2 of the talk. So till now, anyone, any doubts? How much space? I've not seen that. Let's check. So the Git basics one, which is fairly large, it's not showing me the size here. But if I check properties, maybe it will. .6 MB. Okay, it's taking 8.6 MB. But obviously that file is, it's not uploaded, downloaded. The entire .git directory is not exchanged every time. So don't worry, you're not exchanging 8.8 MBs every time.
Hello.
Yes, Jay?
I want to say that there's a shortcut for seeing properties, like instead of click, we can directly do Alt-Enter.
Okay, sure. And there's also a command line way of checking it. You can just run du-c. Du is disk usage. So yeah, Thank you so much, Jay. So I'll just press Alt Enter here. Ooh, nice. Thank you. New shortcut learned. Anywho, anyone, anything else? Any doubts? Okay, great. Now we'll get into how how Git is working. How is this stuff going on? What the hell is going on? So we are going to create so Git creates a graph. Okay, so we are going to sort of okay, this loads. Yeah, we're going to sort of create a graph here using all these objects and all of that. So yeah, just hold on. It's going to get pretty exciting now. So yeah, this is if you're still there, thank you so much. This is the meat of the talk. Okay. Now, let us create a new folder and let us track only the object directory now. Okay. What do I name it? Git internal working. I'll name it that. Internal working. Okay, let us navigate to that. Let's close all of these. Oops, wrong terminal. Let's open bash. Great. Okay. What am I doing? Yeah, sorry, I have to I have to get inside that folder. Okay, we are inside that folder now. Okay, now I'm going to initialize the repository. Okay, initialize the repository. Now let me create a file, touch file1.txt, enter. Okay, and if you remember on adding right now there's no change in the directory. If you remember, I'm just going to list it out for you. Okay, no changes here. cd ls/objects. So now it's all going to be about the objects directory. Okay, so right now nothing in the objects directory, only the info and pack directories. Okay, so let us add this file now. Git add dot. Okay, it's added. Let me show you Git status. Okay, file1.txt. Okay, so we have a file here. Now let us go to the .git directory now. cd.git/objects. Okay, ls. Ooh, we have this E6 thing again. Okay, what are we going to do? We are going to cd into it, and this time you'll get to see the contents. Don't worry. We are going to ls again. Okay, this is the file now. All right. Okay, now we are going to print it out. Obviously gibberish as per usual. Just to get this down below. Okay. Okay, so gibberish. Now let us actually print out some. Why is this gibberish first of all? So let me tell you, I should not have done this, but anyways, why is this content this way? So Git uses a compression library called zlib. Okay, it's zlib. Okay, it uses that library to compress the contents and store it. Okay, so that obviously if you store the entire file in its normal textual or however it is, it's going to be huge and it's going to occupy too much space, right? So it compresses this text or whatever into a using the zlib library. Okay, and that's why when you print it, it prints out something like this. So what do we have to do? We have to decompress that. Okay, how are we going to do that? We're going to use a utility called OpenSSL. Okay, we're going to type OpenSSL -d z. Okay, sorry, it was. Wait, let me check the command. I forgot. It was open zlib -d. Okay, zlib -d. In which file? In this particular file. Enter. Okay, we have some random stuff here. Okay, blob 0 something something. Okay, what is this? I'll explain in a bit. Hold on. For now, what is the name of the file? The name of the file is 9de something something, but the SHA starts with E6, right? So E6 9de. What are we going to do? We're just going to copy this and we're going to paste it here. Okay, I'll tell you what's going on. Give me a minute. E69DE. Okay. Great. So we have this particular blob here, some random blob going on. Okay. And the content of it was blob 0. What is it? Why is that 0? What is going on? I'll tell you. 1 minute. Okay. Now let us come out again. Okay. We're in the normal directory. I'm going to add some content to it. Okay. I'm going to say echo Git good. Okay. Into the file1.txt. Okay, just to see that I did something, file1.txt. Okay, I have git good in that. All right. So now let us add this file again. Okay. So if you check git status again, by the way, git status -s, and now you know what we are checking. We are checking the index file right now. Okay, so Git has realized that whatever this is not the same as what we have stored. Okay, it has compared that. It goes to the index file and checks, okay, what is the previous version? Is the previous version same? Nope. So yeah, some people on YouTube are asking, screen is not visible. We know that. Okay. So yeah, we have the status. It's checked that, okay, it's not the same. It's compared it. Okay, now we are going to add it. Git add. Now you can ignore the warning. Git commit. Oh, sorry. Thank God. Oof. Okay, so thank God it didn't commit. Now let's go and check the directory again. cd.git/objects. Enter ls. Oh, another one. 65 this time. Okay, so E6 already existed. We saw that. Now this has been created. 65. Let's get into this. Okay, cd 65 ls. Oh, another hash. Okay, let's copy this. Let's obviously cat it out first. It's going to be gibberish. And now let's use the OpenSSL command to decompress it using zlib. Paste. Enter. Okay, finally some output. Okay, what's going on? Blob is the file type, obviously. Okay, so Git has 4 objects. I forgot to mention this before. I don't know why. So Git has 4 objects: commit, tree, blob, and tag. Okay, we're not going to get into tag because it's not really important to understand the working. We're going to get into blob, tree, and commit. Okay, so blob is the first type of object we're getting into, and this is a blob object. Okay, a blob object is basically to store the content of the file. Okay, so content of the file is stored in a blob. Blob stands for binary large object. Okay, so blob is the object type, file type. Okay, then there is a space, and then there is 9. 9 is the length of the content. Okay, let us start counting. 1, 2, 3, 4, 5, 6, 7, 8. But there's 9 written here. Why? Because when you use echo to add some content to the file, it adds a new line, that is a \n character that is not printed. Okay, and after 9 there's a null character called \0 that is also not visible here. I'll prove to you that this actually exists. Okay, so that means if this is what was decompressed, and the decompression of this particular file, the contents of this file could generate this. So that means if I try to generate the SHA-1 of this, it should generate this particular SHA-1, right? Okay, so if I try to create a SHA-1 from this particular string, it should create the same SHA back again, right? Let me show you. So if we use OpenSSL again, we don't need to use that. I just need to print it. Printf. Okay. Syntax. Okay, there's no brackets. I'm just going to write this again. Blob 0 git good, copy, paste, and I'm also going to add the \0 and the \n that I told you that exist but are not visible. And then we are going to pipe it to SHA-1, SHA-1 sum, which gives you a SHA-1. Okay. Now pray to God that it's the same one. It's the same one. Yes. Anywho, so 65 was the first 2 letters, and the remaining 38 were this, right? So 65 D539. 65 D539. Okay. So what happens? What is happening here? What is Git doing? So what is Git doing? Git is basically sort of creating that hash from this particular string format. Okay, it is saying, acha, first the file type, then a space, then the length of the file, then add a null character, and after the null character, start whatever the user wanted to store. Okay, and so that is exactly what happened here. Okay, so what you did, okay, we have this format now, let us hash it. Okay, once you hash it, it uses that hash as the name of the file for bucketing, right? So for it, once the hash is generated, it takes the first 2 characters, makes a directory out of it if it doesn't exist, and whatever 38 characters are remaining, it creates a file. Now, what are the contents of the file? Git takes the same string that it used to that was used to create the hash. It takes the same string and just compresses it and stores it in the file. Okay, so that is literally what is going on. Okay, so that is how your content is being stored. Any doubts here? And obviously, one second, before you ask doubts, so I'm not going to print the content of the file every time using this huge command. I'm going to make it simpler for me. Git provides a plumbing command. I'll tell you what plumbing is. Hold on. So there's a plumbing command called git cat file. Okay, and I can print the what do you call it? Contents of the file. Okay, copy and paste the first 5-6 characters I have. Okay, git code. Okay, and what is the type of the file? There is a flag called type T. From that, okay, it's a blob object. Okay, and the content is this. Okay, that's just Git's way of doing it. Okay, now what is, I said this git cat file thing is a plumbing command. So Git has 2 types of commands. There is porcelain commands and there is plumbing commands. So imagine a wash basin. Okay, the talk, but anyways, imagine a wash basin. So when you're using the wash basin, it's a nice porcelain kind of thing and you're using it. So porcelain commands are higher level commands. Some stuff like git commit, git add, git status, and all of them are git pull, git push. All of these are porcelain commands that we use in the daily life. And plumbing commands, so imagine the basin, what is there below or behind the basin is basically the plumbing of the basin, right? So that is why these are called plumbing commands, wherein they are low level commands that initially Git was made using these low level commands, but so that it becomes easier, relatively easier to operate Git, that is why these porcelain commands were created. Okay, so that is why we are using this, making use of this porcelain command that is doing all of what we did internally. I don't know if it's the same way that it's doing it, but I'm sure they have a better way. But it's doing all of that decompression and all of that stuff internally, and we are going to, from now on, I'm not going to be compressing and decompressing using OpenSSL. I'm going to use the command that Git provides. Okay. So yeah, this is all about blob objects, wherein Git basically, to create the SHA, it stores, before I talk about SHA, it basically compresses the contents using the zlib library and stores it in a file. What is the file name? So before compressing, it creates a hash of that, whatever content that entire string is, it creates a hash of this entire string. And whatever hash is generated, first 2 is used to make a directory in the objects file, in the objects directory, and inside that 2-letter directory, the 38 characters are the name of the file. And inside the file, that same string is compressed and stored inside the file. So that is how the blob objects work in Git. Any doubt regarding blob objects? Because we'll be going to commit and then tree objects after this. So any doubts? Anyone? Anyone still paying attention? But yeah, if you have any doubts, let me know. If you understood, sure. Yes. So there is Git clone has another flag called depth, and you can enter the number of commits history you want to go down to. So if you just say git clone and enter the url.git, then that will clone the entire repository, all the history of it. So just imagine cloning React's main repo. You are getting all that history. So rather than that, to make it faster, and that'll take lots of time. Okay. So what you can do, as Karthik said, just enter the depth 1 or depth 2 command, and you just get the last 2 commits and the files for the last 2 commits. You won't get every damn blob object of every history that existed. So the clone becomes faster, and yeah. But anyways, anyone having any doubts or anything? Okay, I guess not. All right. Now that we okay, someone has a doubt. Where is the meet? Confused, yeah. Oh, Karthik is talking. Okay, no problem. Okay, let us now update our blob thing again. Okay, so we saw that we have, if we go back, if we ls, see we have 65 and 66. Okay, so that is the 65 is another blob object that we saw. Okay, So let us just create one more. Okay, I need the CDs. It would be 3. Okay, so we have these two blob objects for now. Okay, now let us commit this finally. Okay, so cd dot ls. Okay, so we have file 1 git status, just to show you, is added. Now git commit hyphen n add file 1.txt. Okay, now okay, we committed. Now there has to be some more changes, right? So yeah, let's get into the object directory again. cd.git/objects, enter ls. Okay, 2 new files were created. So we had E6 and 65 here, right? E6 and 65. So 81 and 88, these 2 directories were created. And so we'll explore both of them. But first, if you check the output of the commit message, we got 88d1d 88b1d. Okay, remember that 88b1d. So let's get into this 88 directory. Okay, cd 88 ls. So you see b1d here. So 88b1d. Okay, so now obviously if I cat this file, gibberish again, obviously because zlib compression. So now I'm going to use git cat file. I'm not going to use SSL, OpenSSL. Git cat file hyphen. Let's first print t, which is the type of. So initially it came out as blob, if you see, when we did the type t. So now let's see what comes. Type t and whatever is the file and enter. What? Why? Oh, okay. Oh, my bad. I have to enter the entire object name. Sorry. cd.stand. Okay, I don't need to do that. I just need to add 88 at the start. I need to enter the entire thing. So commit. Okay, so we have landed on a new object type called the commit object type. Okay, so now let us see what this commit object type has inside it. And you don't need to write the entire 40 characters here, by the way. You just can write the first 5, 6. So yeah, let's print it. Okay, so we have another object type that we see here, tree, and that is another thing. And if we see here, 81. So if you see in our thing, we have 81 here. Okay, so things are starting to get a little more clear. So yeah, let's just see what's going on. Okay, for now. Then we have, so we have this tree thing. We'll look into it later. We have this author who is Harsh Kapadia, and again Unix epoch time, the Unix epoch time, then the time zone, then committer. So please remember that author and committer are 2 different things. You can be the one committing the commit, but someone else can have given you the patch for the commit. And so that has usually happened where Karthik sort of does. Karthik is someone in the meet, by the way. He's very active in the chat right now. So he does some commit for me, and maybe he doesn't have time to commit or something. So he sends it to me. Okay, so the author is Karthik Soneji, but the committer is me. Okay, so just so that there is just so that you know there is a difference between author and committer. Okay, so those details are present in the commit file and obviously the commit message. Okay, so now you're understanding when you're typing git log over there, it has that SHA over there in those files, but how does it know the commit message? That commit message is stored in the objects directory. Okay, so it has that SHA. Okay, I have the SHA. Git says, okay, I have the SHA now. Let me go to the objects directory to find that. Okay, let me go into that and print the find the commit message. Okay, I found the commit message, and it prints that commit message for you to see when you type the git log command. Okay, if I type git log right now, see this add file 1.txt thing is coming. Everything is coming from here. The details of this particular commit. Okay, the commit will be written in the logs file. Okay, but where is the details of the log file? It is all here. Okay, so all this author, date. If you see the rate, it also gets this printed in a good manner, in a proper manner. This plus 530 remains the same, but the Unix epoch time has been printed out in a user-friendly manner. Okay, so that is sort of what is going on over here. Yeah, so now let us get into, okay, so I explained to you what this is. Okay, now let us get into this particular file. What the hell is this? Okay, tree. Okay, so we saw a new commit, new sort of thing called the commit object. Okay, what is the hash of that? 88b1d. So commit. Oh. Okay, so we have this particular commit right now, and we have a commit message. Let me just add that. Add file one.txt. Okay, so for now we have this particular commit, okay, and we have these two blob files, okay, and now we have got a new object type. Where are you? The tree object type. Okay, so let us see what this is. I copy that again, git cat file -t, paste it, enter. Okay, tree object type. Okay, now let us pretty print it. Oh, again 10644 is the file mode I had explained to you. This is octal number. Okay, and this is the file type. Okay, whatever this file is, which file is it? Okay, it's a blob file. And which is the file you're referring to? The 40 character hash and the name of the file. Okay, now let's see what's going on. Okay, so there was this particular tree file is pointing to 65D53. Okay, so there is this commit object was pointing to some tree object, which in turn was pointing to some 65D53. Okay, if it's 65D53. Okay, so I think now we're understanding what is going on. So it's something like this. Oops. I think it. Okay. Something like this is going on. Okay, so we have a commit message here. It's pointing to the tree. And the tree file is pointing to the blob file. Okay, and this is how Git is sort of creating a graph. Okay, it will sort of get more complicated as we do more things and do different types of things to show you how it's actually working. So yeah, the initial basic thing of how Git is working is this. Okay, where there's a commit object, there's a tree object, there's a blob object. Blob object stores your data. The commit object stores. Okay, this is the commit, and then commit objects points to a tree. Okay, this tree points to which all the files are there in this particular commit. Okay, these all files. Okay, so right now it's pointing to only one of them. Okay, so to get it consistent with our sort of example, let us copy this one. Okay, and let us copy this as well. And let us copy the text message as well. Sorry, this takes some time. I'm sorry. This is done. Let me delete this guy and this person. And it should be file1.txt. Okay, so what is going on? We have this particular thing. Okay, this particular structure going on right now. Okay, and this still exists here. Okay. Now, why? So yeah, this exists like this. Okay, did you get this? Now, why is this not being pointed to? Because file1.txt, this is when it was created, right? But if you remember, I had just added some content to it, so that generated a new file. So initially we had E6, but then we had 65, right? So that is why whichever is the latest version of the file, the tree will point to that. Okay. Oh, I need to write the hash of the tree as well. Okay. So right now this is a situation. This is a waste object now. This will be garbage collected later on. Okay, because this blob is basically not being referred to by any tree, right? So this is just present over there, and once garbage collection runs, this particular blob will be deleted. Okay. Now, so we have discovered all three types of things, and we are now noticing that, hey, Git is creating a graph. Okay. Now, let us sort of create a directory. I think that is the next thing. Oh yeah, I need to just create one more commit to show you another thing. Okay, let us create a new file, touch file2.txt. Let me just add something to it. Echo abc to file Yep, file2.txt and git add. Oh, I'm sorry. Oh, where did I create the file? God damn. Move file2.txt. Oops, I created in the wrong directory. Now we are back in the main directory, in the internal working directory. Now I can create the file. That's file2. Echo something into it, and now we can run git add. Okay, you can ignore the warning. Let us obviously go and check the object directory. And just to show you this time, I'm not going to print out anything. Objects. Spelling. Okay, so if you remember, we had just had 65, 81, 88, and E6 before. New file is 8b. Okay, and I'll prove to you later on that new file is 8b. If you don't remember, don't worry. Okay, so this 8b new file was created. Okay, I'm going to git commit now. This is just to show you. Okay, now git commit -n add file 2.txt. Okay, done. Okay, now let us go and check the tree again. Okay, so git gives us this SHA again, so we are going to use that. Okay, let's take the first 4 sort of things. Oh yeah, we need to check the object directory as well. cd.git/objects ls. Okay, so now 2e was created and eb was created, right? These two are created. Don't worry. Yeah, you don't need to remember all of this stuff. So I'm just going to use whatever git gave me here, the first 5 letters here. I'm going to say git cat file, print it please, and paste, and enter, sorry. So now, okay, git is saying, okay, this is the cat file. Oh, I mean, this is the commit you want me to print. Okay, okay, I printed the commit, and okay, it's telling the new tree is this particular tree. Now there's a new line here. Author, committer, and commit is the same as before. Now there is a new line here. There's a parent. Okay, so what is going on? Let me first create an object here and show you. Copy this again, paste this again. Okay, so what is going on again? I think you understood it, but I'm just going to do it so that I create the graph for you in the end. So what is the commit message? 2, 3. Okay, so I have created this now. Okay, and the commit message was add file. My bad. I'm sorry. Okay, so this was the commit. Okay, and it told me that okay, this commit has this particular tree EB6B8. Okay, so I'm just going to do that. EB6B8. Okay, so this tree, and it told me it has a parent called 8BB1D. 8BB1D. See, so that means there is a pointer thing going on here. Copy this, paste this here. So yeah, so basically Git is literally just pointing stuff. Okay, so it is like, okay, this commit has this parent, and this is the tree. Now let us check what the tree is going. What is going on with the tree? Okay, so again, git cat file, and first letter is E B E, and I type 1 EB 6B. Okay, so now if you remember 2E, that was the new directory 2E. Then there was the tree EB6. So again, there's a new directory called EB here. Okay, and we've gone into the EB6B file. Okay, it has 2 things here now. Okay, so what's going on? So again, this one, there's a blob called file1 65D5. Okay, 65D5. So that means this is pointing to 65D5. Okay, and okay, it's black in color. God damn. Okay, so now what is going on? There's one more file here, which is called 8BAEF. Okay, now what is this 8BAEF? We need to check this out, because this we saw was the initial one. But what is this one now? This one, obviously, I think you've got it, but I'll have to show you. If I copy this, obviously the blob, so you understood what it is. I'm just going to print it out to show you. Okay, ABC. That's what we put in file 2. Okay, so copy this, paste it here. Okay, and this is file 2.txt. Okay, so I think you're sort of understanding what is going on, right? It is sort of creating a directed acyclic graph. Don't ask me. I'm not a CP person. Anyways, so yeah, this is what is going on. And one more thing now to show you. Let's check what the head file is doing. Okay, if we go there, we say cat.gits. Okay, we are cd. Okay, now we say cat head. Okay, it's saying, okay, go to this particular file. Okay, let us go there. cd ref /heads. Okay, and then I'm going to do an ls here just to show you. Okay, there's main. Let's cat main. Okay, main is pointed to who? 2e83a. Who is 2e83a? Oh, this one. So that means the head is pointed to the latest commit out there. Okay, so for that I'll have to shift everything up. Okay, shift everything up, and we can get in Mr. Head over here. Okay, it still didn't fit. No problem. So whenever you are in a branch or whatever, this is how Git knows that, okay, you know, it is creating this kind of a graph, and you check out, suppose you just check out this random particular commit, and then Git has to sort of figure out where do I sort of find the files. Suppose you check out this one. So Git says, okay, fine. Let's get into this commit ka file. Okay, which is the tree? Okay, this is the tree. Okay, Mr. Tree, which files are you pointing to? Okay, these two. Okay, let us uncompress these files and show it to the user in the normal folder. Okay, so that is how this entire graph is sort of being created. Okay, now, and obviously this is being no longer, this is file 1 only, but it is the previous version of file 1, and it's not being referred to by any tree. So this is going to be garbage collected. Okay, so this is sort of the graph that has been generated till now. Damn it. And I have to do shift tab and stop. Okay, great. So for now we have this kind of a graph. Okay. And this is, I basically did this just to show you that, okay, there is a sort of a parent thing going on over here, and the head is, it's creating a linked list basically. Okay, so this commit, the entire commit stuff is going to be a linked list, and the entire thing is the directed acyclic graph. Don't ask me. So yeah, that was parent commits. Now we'll sort of create a directory, and let's see how Git handles directories. Okay, so let us get back. Yep, ls. Okay, so we have just these two files, and now let us create a directory. Make directory dir1. Okay, so directory 1. Okay, let's get inside the directory dir1. Oops. dir1. Okay, now is there anything here? Obviously not. Okay, I'm going to create a new file here. Touch dir1 file.txt. Okay, I added this file. Let me add some content to it. Touch touch. Oh, not touch, echo. Echo abc. No, not abc this time. Let's okay. To dir1 file.txt. Okay, we echoed that. Now I can hear Karthik laughing, but anyways, yeah, so we've done that. Now let us go back to our main folder. Okay, internal working of Git. Now I'm going to do a Git status just to show you what's going on. Okay, so now it's showing us that it's untracked, obviously. So I'm going to just randomly add it. Okay, git add dot. Okay, now you can ignore the warning, and now I'm going to commit it. Okay, do I need to show you objects now before committing? Should I? Not needed. Okay. So I mean, you know what's going on now. Anyways, so what am I going to do? Okay, let me do it. cd objects slash. Okay, just so that we have a reference. Okay, now let us go to committed cd slash. Okay, git commit -m add dir1. Okay, we've done this now. Okay, great. We again have a hash. Okay, so now again we are going to use this hash 1 2 3 4 5. Yep, we're going to use hash git cat file -p paste. Okay, great. So again we have one parent is 2e983 2e83. Okay, this is the parent. Great. So we are getting that same parent. Okay, we have a new tree. Let us explore that tree. Let me just update this so that you'll understand things better, because this is slightly complicated now. Okay, let me clean this up. Mr. Head, just come down here, and I need you again. Copy paste. Like this here. Okay, so now we have a new commit again. What was the name? I have it copied. I summoned Cortana by mistake. She's not going to leave me now. Yeah, 24CF, that was it. Oh God, please go away. It's still on. Anyways, this was 24CF, right? Yep, 24CF is here. The parent is this one. So I'm just going to copy this one and extend it obviously to here. Hi.
Easy.
Yeah. I'm putting too much time, so I'm like, yeah, I need to hurry up. But yeah, so right now this is the situation. Ignore this for now, obviously. So head is obviously pointing to the latest one. I'm not going to show it to you again. Commit message, damn it. So commit message add dir1. Okay. So this is the commit that we have right now. Okay, let's go and explore this tree. Git again, paste, enter. Okay, we have another tree over here. What is going on? Okay. Also, by the way, if you see here, if you remembered for symlinks or git links, there was the value was supposed to be 0 for the Unix file permission, if you remember. So let me just show it to you. Git directory, index. Oh yeah, the index. Yeah. Yeah, symlinks and git links have the value 0 in this field. For the Unix file permission field, this is all going to be zeros. So if you see here, where is the terminal? Yep, this is not a regular file. This is a git link or a symlink. I think it's a symlink, but I'm not sure. So yeah, yeah, this is the one of the git link or symlink. It's not a regular file. Okay, so let's go and check what this tree is all about. Before that, let's just see 65D5 and 8BAE. Okay, 65D5 and 8BAE. Okay, so this is pointed to this as well. Shift L. You're pointing to that. And you're also pointing to this one. Okay. So, okay, first two files are done. Okay, these two are done. Now let's see what is going on over here. Okay, let us go to git cat file and let's copy this and here. Okay. So that means this is whenever there's a directory, Git creates a tree object for the directory and gets inside that tree, whatever is there in that particular directory, it goes into that. Okay, so just to show you how it's going on, I'm not going to create the graph because we are running short on time. Oops, wrong one. So yeah, it creates a tree. There's a tree, then whatever file is there, that stuff is going on, and then wherever there's a directory, there's a tree for that directory. And so the initial tree is pointing to this tree, and this tree is pointing to whatever files are there in this directory, one directory. Okay, so that is sort of how that particular graph is going on from tree. Okay, so what we are going to do right now is obviously going to create a new tree object here. First I need to enter the hash of the tree. Okay, this. Okay, we have the hash here. We need to create a new tree object. Copy, paste, drag it here. I know I'm not the best with Figma because I've never used it as much, but yeah. Anywho, what was the new tree here? This was 4, 5. Copy. This is the new tree that was created. Okay, so Shift L. This guy is pointing to this guy. Easier. And now, ooh, that's weird. Let's keep it that way. Weird, but sure. Anyways, okay, you are not pointed to any blob, so let us delete this guy. Okay, so this is there. Oof, how do I bend this arrow? But anyways, is there a way to do it? Okay, no. Okay, so and this is pointing to another one. Okay, so I should just have copied that down below, but anyways. Harsh. Anyways, yeah, copy the first 5 here, 3. Sorry for making you wait for this, but oh god.
I'll narrate it. 6A15C. 6A1, yeah.
I copied it. But yeah, Shift L. So yeah, this is sort of how the graph is created when there's a new directory. Okay, so this was we had. If we have made a commit, then there has to be a tree object. Okay, so and we had not changed these 2 files, so whichever is the latest version of these files, it will keep pointing to that. Okay, and then whichever is the if there's a new directory, so every directory has a tree of its own, tree file of its own, and whatever is there inside that particular directory, that is present in this tree file. Okay, and this was which file? Yeah, dir1 file.txt, and obviously. Okay, so this is the file, this is that file. Okay, so again, this is how the graph is being created. Now we get into even more stuff. Let's see how stuff handles, how Git handles more stuff. Now let us rename a file and check how Git handles that. Okay, I'm sure you've got how it handles it, but sure, I'll just show it to you. Okay. Okay, before that, before I get into renaming, does anyone have any doubts? Karthik, I don't have an idea of that, so I'll take that up later maybe. And you can take that up at the end, but I don't know what that is. Anyone else? Any doubts? Okay, I guess I'm presuming everyone has understood it. Okay. So now that we know that Git is creating this sort of a file structure graph, how does it handle renaming of files? Okay, let us check. Let us go to, yeah, we are in this. So ls. So I'm just going to rename file1 to file.txt. Okay, and I forgot the rename command, so I'm just going to use the move command to file.txt. Okay, ls. See, we've renamed it from file1 to file.txt. Okay. Now what am I going to do? I'm obviously going to do git status to show you what is going on. Okay, it says it thinks that file1 is deleted and it's showing question mark untracked new file, this one. Okay, but now let me git add it. Now let me show the status. Okay, so you can see that Git is smart enough to realize that okay, the file is renamed and it's showing an R over here. Okay, So git commit. Let me show you the objects directory. ls the .git / objects directory. obj ects. Okay. Anyways, now let us commit git commit -n the name file1.txt. Should I read file.txt? I'll just write it. We did that, and if you see here, Git is giving us the output rename file1 this to this. So yeah, Git has realized it is smart enough to realize. Now, how did it handle it internally? Let's see. So ffd3b again. So git cat file -p pretty print and enter. Now, if you see here, again, same thing again, parent is 24CAF. I'm sorry I have to do this again, but I have to. So yeah, I think this is the last one that you were going to do. So yeah, just bear with me. Sorry for taking so much of your time. This is done. Go up. Okay. So you can come down and let us get you in again. Okay. And we'll touch you to this. So obviously I'm not going to tell you again that I'm not going to share it to you again, obviously. Shift L and go here. Okay, so yeah, we have this one 24CAF, this which was this one, and this particular commit has its first 5 as this. I'm just going to keep the commit message as rename operation. So yeah, this is done. Okay, so this is going on. Then there's a tree. Obviously, the tree 3, 4, 5 copy. Okay, so this tree is done. Now let us explore the tree again. Okay, 93. Okay, so tree is again pointing to 8 to D4 again. So 8 to D4, this guy, because not changed. Okay, 65 D5 3, 65 D5 3. Okay, pointing to this and pointing to 8BAE, 8BAE. Okay, so it is pointing to all three. So what is the change? The change is here. Instead of file, it has just renamed it to file1.txt. So basically, it has just basically said, okay, to hell with your name. Okay, what is red? Oh God, color picker, red, great. So it has just said to hell with you, and increase the stroke to 5. Okay, so it just says to hell with your name. I'm going to basically just rename you to file.txt. Okay, so that's all it did. Everything else, it is pointing to the same people again. Okay, so let me draw it for you. Control L. Then pointed to this dude here. Okay, then this dude pointing to this one, and this same dude pointing to, oh God, I'm so bad at this. Control and pointed to this. Okay, so all it did was that it just renamed it. Okay, renamed the file. There is no other change, so it is not storing duplicate files. It is not. That is how Git is being space efficient, right? So if the content has not changed, it is not going to change the blob. It is only and only going to change the name of the file, and the name of the file is not used while creating the blob. The name of the file is only stored while in the tree file here. Okay, so now you can sort of imagine how someone who thought about designing this thought that, okay, file renames, I should not include files in this. Why? Because if there is a file rename, then I will not be able, then I have to create another blob object, which is not space efficient, right? The file can change. So, just think in yourself, oh, damn, that kind of thinking is so awesome. I should remember that kind of thinking. So that is why these are the sort of design decisions and software architecture decisions that you should, you get to understand from by getting into the internals of stuff. Because someone thought that, okay, while creating the blob object, all that blob length of file and the contents, I should not include the file name because it can keep changing. And if I keep changing that, then I'll have to keep on creating new blobs, which is which is inefficient storage method. So that is why that's another good way in which Git handles stuff. Git is storage efficient. And so yeah, this is the kind of stuff that is created. Let me just check if we have something remaining. Renaming, I'm going to skip this and the info and pack files. Let's not get into that today, maybe some other day. So yeah, just to let you know, the info and pack files that are present over here, these are basically just, I'll show you a pack file. Give me a minute. See, let's open another one. cd git basics cd.git/objects/pack. It was a directory. Okay, I'm in the packs directory. I'm in ls. So it has two files called pack something.index. IDX stands for index, and pack something.pack file. Okay, so I'm just going to show you what that is. There's a command for that, git, another plumbing command, git verify pack, and the name of the file. I hope I'm not missing something. Let me check. What was the command? It was -v verbose. Okay, -v, and crazy, right? So what is so remember, this has 397 commits, so it is bound to be huge. Okay, I didn't expect it to be this huge, but yeah. So you can imagine, right? Because every commit is sort of creating two files, and every add is a file, every blob. So yeah, there's a lot of stuff going on. So yeah, basically, to transport objects, right? To like sort of transport objects over the internet and stuff. So that's why Git creates this sort of file wherein everything is stored together, all the contents and everything, the details of the file are stored together here. Okay, and I think one of these numbers is the file size and stuff. I've not explored this file as much. Okay, and wherever you see this particular thing, it's basically pointing to a parent. So the other part that I'm skipping is actually about if there's a huge image file and you've made a small teeny change in that same image file, you just add a full stop maybe to the end of the gibberish output. You just add a full stop and add that and commit it. So Git is not going to store two huge 4 MB images, right? If you have a 4 MB image and you sort of print it out, it prints gibberish, right? So if you add a full stop at the end of that, you're making a tiny change in that image. So it's not going to store 4 MB or 4 MB again, right? So what it does, only for the latest file, it stores the entire 4 MB, and for the previous file, it just stores the change. For the new one, it just stores the change, and it stores the initial. No, it stores the changed, the newest change that you made stores the 4 MB for that, and the old one, it just stores whatever was not there here. Okay, so I mean, it just stores that, okay, I just have to remove the full stop if I want to get to the older one. That's why the file size becomes smaller, and then the parent is listed here. Okay, so that, I just have to remove the full stop is stored in the older one, and so it says, okay, if I want to construct that, go to this particular file, get this entire thing, and remove that full stop here so that you get the old image. Okay, so that is why to again be more storage efficient, Git will not store the entire 4 MB image again. It will just store the things that have to be removed to get to the older one in the older file and indicate a parent over here. Okay, so that is why you see this stuff over here. There must be a huge file that is being done. So yeah, and it's especially there for blob objects. See, there's a lot of parent thing going on. Huge blob files modified again and again, and so yeah, there is parents. Now you must have a question that but you had told me that any previous blob files that exist are garbage collected, but only files that are not referred to. So if this file was modified again, but there are still files referring to this file, right? That's why this will never get deleted. That's why this parent concept comes in. Okay. If there is a file to which no one is referring to, this will definitely get garbage collected. Okay. So I can delete this guy. So yeah, this is what is sort of going on. So yeah, this was the sort of talk. I know I extended way more than required, but yeah, I hope you've understood something, and I think it's only the committee members now. But yeah, thank you so much for coming in, and this was the talk. Any doubts? I'm open to doubts now.
Hello, Harsh. I have a doubt. Can you
Yes,
explain that parent one again?
Sure, no problem. Actually, I was going to demonstrate that, but it's too long now. So the thing is that if you have an image, okay, if you have an image and if you modify that image, so how do you modify an image? What am I talking about? So if you print out the image in the command line, it will print out gibberish, okay? Like, you agree, right? If you print out an image in the command line, if you use a cat image file, it's going to print out gibberish. So at the end of the gibberish using Vim, you just add a full stop at the end. Okay, so that's a small change in such a huge 4 MB file. Okay, so now when you say, okay, Git have modified this, add it, commit it, how is Git going to store it? Git is not going to store 2 different 4 MB files. What does it do? It will only store the newest file. Okay, the newest file will be stored full. So 4 MB newest file is stored. In the old file thing, how is that stored? It stores only the change which should be removed from the new one. Got it? So it only stores that, okay, remove that full stop at the end. The old one stores only that much. Okay. And so when you refer to the old one, okay, get me the old version. So it says, okay, I'll take and it has the parent written on the side. So it says, okay, go to the parent, get me the parent, and then, okay, I have to remove that full stop. Okay, I'll remove the full stop and show it to the user. Got it? And
Okay,
why
yeah, so
is
the-
one second. Why is the, one second, give me a minute. And why is only the new one stored? Because obviously you are going to refer to the new one more, right? I mean, logically speaking, you are referring to the old one is going to be pretty rare. So that's why, again, a design decision that you have to remember, store the latest one and not the older one, because the older one is not going to be referred to enough. So again and again, if you just store the new change in the new file, then you are going to have to get that file and add the new change and show it. Instead, store the new file and show it directly. And only if you want to go to the old one, which is pretty rare, then you remove whatever was there in the new file to show the old one. So that is the kind of thing.
Okay, yeah, got it.
So again, on one more design decision that I was like, oh wow, that is like so nice. I would have stored the old one, and the new one I would have just stored the changes. So yeah. Anyways, any more questions?
I'm actually facing an issue. This is like very stupid.
No
I
problem.
can't open your the website that has all the GitHub commands. Like I've been trying this since yesterday. Do you mind if I share my screen?
Yeah, I'll just paste a link to see if you can open that. That's good.
I can't.
You can't open this link?
No.
Whoa, present your screen.
1 second.
Okay, anyone else having any doubts? Till Nidhi presents the screen. Okay, sure, no problem then. Whoever doesn't have a doubt can take their leave. I'm done. Yeah, Nidhi, present whenever you're ready.
Yeah, is this visible? Is my screen visible?
Yeah.
Yeah, sorry, I was on mute.
Yeah, okay, so this is all I'm getting.
How?
And I even tried changing browsers. So like this is Firefox. Again, I can't see again.
I have no idea why. Can someone else access Tushar? Can you access it?
Yeah, I can. I just saw.
Oh.
I even tried using the command line.
Oh, you did duplicate, damn.
Yeah.
Wow, I don't know why that is happening.
I think you might have some DNS.
Yeah,
error,
DNS
so
issue.
you can try clearing your DNS cache.
Maybe just flush your DNS and check. Oh, that won't do
What is a
anything. But, okay, let's not get into that right now. Maybe you can look that up later. But yeah, so Try it on your mobile, see if it works on your mobile. If it's working for
Yeah,
others.
it is working on my phone.
So
don't know
that
what
means
the
your
issue
laptop has some DNS issue. Something is going wrong. Just try what Karthik told you on the command line. Look, Karthik, can you please just type the entire command so that you can just copy paste and see what's going on? Okay. Anyone else? Any doubts?
Thank you.
No problem at all. And even after the session, you can sort of ping me on what Telegram or something if you're in the group. Nidhi, if you have a doubt, let's look up. Let's look up.
Yeah,
let's get into whatever is your problem. Try whatever Karthik has told you and let's see what happens. Okay. Anyone else? Any
the
questions?
thing. It just says I need to install the. I guess.
Oh yeah, just install NSLookup then.
Yeah. Thank you.
Harsh,
Yes, Chirag.
when I get that E6 folder initially, then after some operations I get again the E6, means I get a hash, then having the same two characters E6. Means in 2 point in time, first I get E6, then I get anything else, then I again get E6. Then those two files would be stored in the E6 folder, although they are not related commits or although they are not.
Yeah.
Okay.
What was the doubt?
No, I wanted to clear this.
Okay, no problem. Anyone else any doubts? Yes, please unmute and ask. Okay, you want to protect your identity, right? So yeah, ask in the chat. Contact Karthik for making bit. But anyways, internal joke. But how can you make one? I don't know. Maybe copy Git? Copy what Git has done, make your own Git. I'm not sure. But yeah, lots of design decisions learned. So anyone else, any other questions? I'm done.
So thank you, Harsh.
No need to thank him.
Yeah, and even if I understood 30-40% of it, and even if I'm going to retain 10 to 20% of it, I'm all right with that, because it is still one step forward. So thank you so much. This was insightful. Thank you.
No problem. And also, if someone wants to refer to, मैं किसको बोल रहा है अभी? Okay. Thank you so much for coming.